Welcome to the Arrays and Loops workshop. My name is Noah Houchins. I'm the computer science TA at the Learning Hub, and this workshop is going to be broken up into two separate parts. The first part of the workshop is going to cover loops, and the second portion will cover arrays. So even though these two topics are distinct, they're very oftentimes used together. So I wanted to make sure that we cover both of them and you can see how they interact with each other. So first, we're going to go over loops because you don't need to understand arrays in order to understand loops. So loops allow code to run multiple times rather than just once. They're used to perform some repetitive task over and over and over without having to rewrite the same steps over and over and over. So for example, if I wanted a program that printed hello 10 times, without loops, I would have to write out this system.out.println hello 10 times over and over and over. And this is not good practice for code. So instead, I can put this in a loop, and it would just be a single println statement, and I could have that loop run 10 times. So there are four types of loops that are broken into two main categories. And those two categories are for loops and while loops. So we're going to start with the while loop category first, since it's easier to implement and it's more straightforward. So a regular while loop is the simplest loop you can create in Java, and it's written like this: while some condition do something, where the condition portion is a Boolean expression, and that just means it evaluates to either true or false. So as long as that condition is true, the loop will continue to run or iterate. So iterate is a keyword that you'll hear a lot used in loops. A single iteration is just one run of everything inside the loop. So if I put in there that sysout hello, every time it prints out that statement, that is a single iteration. And this condition up here is checked in between each iteration. So if I have more code, more lines down here, this condition will only get checked once everything inside of our while loop has run. If the condition is false before the loop starts, then the loop will not run at all. For example, if I say while false, we get this error here because we have unreachable code. So it actually won't even let us run it because this will never run. Alternatively, we have an infinite loop. If we type while true, true will always be true, and therefore the loop will never terminate. So this line will run forever. And you can see that down here. It just keeps printing hello. The other type of while loop, because we're in the main category of while loops, so this is just a regular, simple, standard while loop. The other kind of while loop is called a do while loop. And the difference with that is that a do while loop is guaranteed to run at least one time. So if we go back to this while false loop, it won't let us do this because the loop will never run. But if we change this to a do while, so do this, and then while false, suddenly we don't get that error because the line in here, anything that we put between those two curly brackets will run exactly one time, and then the loop will terminate. So in other words, having a do while false does nothing special. It's the same exact thing as just putting any single line of code, but I wanted to demonstrate the difference between a while loop and a do while loop. So a while loop checks the condition first and then runs the code. A do while loop runs the code first and then checks the condition. So it just changes the order. Now, the other category of loops are for loops. So writing a for loop involves more steps than a while loop, but it still functions identically to a while loop in the sense that they both make code run multiple times. So the most common syntax for a for loop is for int I equals 0, where I is less than whatever the number of iterations. And remember, iterations is just how many times the loop will run. Then we have I++ here. So unlike a while loop, it can be obvious before a for loop starts just how many times the loop will iterate. So if I put in here a 10, we know that this loop will run 10 times. And now I want to break down exactly what's going on in here because this can be kind of intimidating. So the first part is int I equals 0. So we're declaring a variable called I. It's an int type variable. And this is going to represent the counter for our loop. It's going to count how many times the loop has run. And that'll determine where we are in the loop and whether we should stop. Then we have the condition, I is less than 10. So this does the exact same thing that our while loop condition does, where we said while something run our code. As long as this condition is true, the loop will continue to run. Then this last part here is where we increment I. We make I go up by 1. So we can alter this header in different ways to make the loop behave differently. So for example, I can start at a different number. I don't have to start at 0. I can start at 1, or I can start at 2, or negative 100. It really doesn't matter. I can also change this number, right? I can say as long as I is less than 5 or 10 or 100, or I can even say as long as I is greater than or equal to, or less than or equal to 60, right? So there's a lot of leeway that you have when writing loops. We can even change how much we want I to increase by. So I++ always makes I go up by 1. If I change this to plus equals 2, now I will go up by 2 every time the loop runs. So if I wanted to write a loop that displays all the even numbers greater than or equal to 6 and less than or equal to 12, then I can write int I equals 6, where I is less than or equal to 12, I plus equals 2. And if I print out those values of I, we get the four even numbers 6, 8, 10, and 12 between 6 and 12. And earlier I mentioned that for loops and while loops do exactly the same thing, but are just written differently. And so I wanted to further qualify that statement. If I want to write a loop that runs 10 times using a for loop, which we had written earlier, change this back to the way it was. Here's a for loop that runs 10 times. Very standard stuff. We can print out I in here and see that I is going from 0 to 9 for a total of 10 iterations. So we're never actually reaching 10. Now I can also write a while loop to do the exact same thing. The difference is I have to declare the I variable beforehand. So int I equals 0. Then we can say while I is less than 10, print out I, and then make I go up by 1 at the end. And now I'm going to comment out this first part, and we should see this exact same output, 0 through 9. When we run it, sure enough, it's the same exact thing that just happened. So behind the scenes, a for loop and a while loop are identical for all intents and purposes. So because of this, you might be wondering, when should you use each loop, or if it even matters? And essentially, it doesn't matter which one you use, but depending on the situation, one loop might make more sense than the other. So the rule of thumb that I follow, and I think is the most helpful, is that typically you should use a for loop when you know how many iterations you will need. So I know I want this code to run 10 times, or I want it to run, print out every even number between this number and this number. We can calculate how many times that will be. And then while loops we would use when we don't know how many times something will iterate. So while this specific condition is true, keep going, because we don't know, for example, Collat's conjecture. I could plug in a number, say 35, and I don't know how many steps it's going to take for that 35 to get down to 1, if you follow the Collat's conjecture. If you don't know what that is, it's a very, very simple yet unsolved problem in mathematics. If the number is even, you divide by 2. If it's odd, you multiply by 3 and add 1. And then you keep forming that step until you get down to 1. And it's unproved whether there are any numbers that will go off to infinity or if every single number just goes down to 1. But that's a thing we can't calculate. We don't know how many steps it's going to be before that number goes down to 1. So that's a good example of when a while loop begins. And now there's still one more loop we haven't covered. It is called a for each loop. And I don't want to get into a lot of detail with the for each loop, at least not yet, since it requires an understanding of some more advanced topics. But I will, at the very least, I want you to see what it looks like and have a general idea of what it does. So the syntax for a for each loop is we have for, and now we need a data type. So some data type will go here, and I'll explain what everything means in a second. And then we give that data type a name. So this is the same as a variable declaration. For example, int I. So this is our data type, int, and then the name of the variable, I. Then we have a colon, and then some collection that we want to iterate over. So a collection is some sort of data structure, such as an array, which we're going to go over in a minute, or a stack, a hash map, etc. Which, again, those are all very advanced topics, so I don't want to get too much into the for each loop. But essentially, the way it works is it assigns a variable to be equal to each value in the collection. So if we have a list of numbers, that would mean that we're dealing with ints. So we could say for integer I in some list. Right now, I would be equal to each value in that list, one by one. So each iteration, it'll change to the next value in that list. So now those are the for loop types. Again, we'll come back to this one and I'll give you an example, but there's more things that we can do with a loop. So before we move on, I just want to see if anyone has any questions about anything that we've gone over so far, because we kind of speed ran that a little bit. So I want to make sure everyone's good on that. And all questions are accepted. Don't be embarrassed. This is a safe space for learning. And chances are, if you have a question, then somebody else probably does too, even if they're not watching this current live stream. Maybe someone in the future is watching the live stream back, so they can't ask those questions. Give it a couple more seconds in case somebody's typing. Okay, so we'll move on. Now we have something called control statements that we can use in loops, namely continue and break. Continue jumps to the next iteration of a loop, and break terminates the loop entirely. So if we bring back that loop that we had before, for int I equals 0, where I is less than 10, I plus plus, and we print out each of our I values, right? We get 0 through 9. Now, if I put in an extra if statement inside here, if I say if I equals 5, continue, what that's going to do is it checks the value of I. It says if it's equal to 5, continue. So we're going to go back to the top of our loop. We're going to skip this line entirely, but only for the value I equals 5. So we should still see a list of numbers, but 5 will not be in it. And now it goes 0, 1, 2, 3, 4, 6, 7, 8, 9. So 5 got completely skipped. Now, if I change this continue to a break, this is going to make our loop end early. So once it gets to 5, it won't just skip printing out 5, it'll skip printing out everything after 5 as well, because our loop will end. So now this just prints 0, 1, 2, 3, 4. So that's how continue and break work. If you're dealing with an infinite loop, if we go back to that while true, unless you want this infinite loop to be truly infinite, at some point you would have to break out of the loop. So we could have some other variable into x equals 5. We could do some sort of calculation on x, and then we could say like if x is even, so x mod 2 equals 0, this means that x is even, then we break. So you could just put this in here. You could say if x mod 2 equals, or if it doesn't equal 0. But maybe you have multiple different conditions that you want to check, where if x is even or if it's divisible by 3, then either of those times you would also break. This just gives you more control as to when you want the loop to exit. Or maybe you want to exit early if you have like a null value and you don't want to get an exception. But the point is that continue and break are both very, very helpful, and you'll see them come into play as you write more and more loops and get into the more complex problems. So that is the basis of loops. If I were to go back and summarize that, loops are just a way to perform the same operation multiple times without having to write it multiple times. And it's very, very helpful, especially when we don't know how many times we want to do something. If we have a variable number of iterations, it's extremely helpful for that. So now I want to talk about arrays. An array is just a list of variables. So if I wanted to store 5 names, for example, without an array, I would have to say string name1, name2, name so on and so on. And this is just impractical. There's way too much typing, it's way too much work, and it's not particularly good. Hard to read, hard to write, everything is bad about it. Instead, we can store all of these in a single variable called an array. So instead of typing all this out, we can use the syntax for an array, which is whatever you want the data type to be, followed by square brackets, and these are important. I'll come back to those in a second. The name of the variable equals new, that same data type from before. The square brackets again, and now inside here, we're going to say the size of our array. So if I were to apply this to what we have here, these 5 names, I would say I want an array that is type string. So we need string, square brackets, the name of the array, which this array represents 5 names. So I'll just call it names, equals new, that same data type, so string again. And now the size is 5, since we're storing 5 names inside this array. So here's our array that stores the same amount of information as these 5 string variables, but we only had to write this one line, this one variable, and it's much, much easier to work with. So whenever you're working with an array, there are 2 things that I want you to keep in mind. Number 1 is that the symbols you use when you're working with an array are those square brackets. This is how we know that this is an array. So 99% of the time, if you see these square brackets, because there is an array. There's one other time that I can think of that they come up, but that's a much more advanced topic, so don't worry about that. So this changes our string variable to a string array variable. Let me use those square brackets again over here to indicate the size. And then the other thing I want you to keep in mind when working with an array is that arrays and loops go hand in hand. So if you have an array, again, there's a 99% chance you're also going to need a loop with it, which is why I wanted to put these 2 workshops together into one workshop. So now, in order to work with the values in the array once it's created, we need to access the array using something called an index. So there's a lot to unpack with that sentence, and we'll cover everything. An index represents a location of an element in an array. So each value in an array, in this case, we have those 5 strings. Each of those strings has a unique index starting with 0. So name 1 here, the first value in our array would have the index of 0. The second value, name 2, would have an index value of 1, 2, 3, and 4. It goes all the way up to whatever the length is, minus 1. So the length of our array here is 5, so the largest index is 4. This is called zero-based indexing, because we're starting at 0. Now, to access the array, that was the other keyword that I used from that previous sentence. To access an array, we need to use those square brackets. That's why they're so important. If I want to make the first name in our string array, if I want to make that first name John, I would have to say the name of the array, which is names, use those square brackets again. And now inside the square brackets, I need to put the index. So since we want to put it as the first name, the first string in our array, that first string has an index of 0. So we're going to put a 0 there. And now I can treat this like any other string variable. So I could say names at 0 equals John. And this is identical to saying something like name1 equals John. These are doing the exact same thing, except the only difference is rather than storing each name in an individual variable, we're just storing them in a list of variables. Now, if I want to print out that name that I just assigned into that variable, again, I can treat names at some index just like any other string. So names at 0, this is the same as saying system.out.println name1. And now this will print out John because we stored John into this first value, first index, and then we retrieved that value afterward. So this is called accessing the array when we're physically going inside the array to change the value. So I like to compare arrays to IKEA furniture. And bear with me, it sounds kind of weird, but I think this is the best analogy for arrays. I think everyone kind of grasps it once I explain it like this. So I'm going to erase all this and we're going to go back to, we're going to rewrite this string names array, but I want to do it step by step and kind of explain where this analogy is coming from. So when I say string array names, and if I just leave it like that, same as if we just declared some int variable without assigning a value to it, this is like saying, I want to put a dresser from IKEA in my house. So you're saying there eventually will be a dresser. But that dresser, it doesn't exist yet. You haven't bought it. It's not in your house. There's nothing there. It's just an empty spot in the corner that you say that's where it's going to be, but it's not there yet. Once we initialize the array, if we say names equals new string array of size 5, now the dresser is in our house. We've put it together and it's in the corner, but there's nothing in it. So we built the dresser, but it's empty. Now we need to fill the dresser or fill the array with stuff. We need to put some strings into the string array. We need to put some clothes into the dresser or whatever else you want to store. So here's where we can combine arrays and loops. Because I could manually say names at 0 equals John, names at 1 equals Mary, so on and so on. But again, this gets tedious and it's difficult to do when you have like 100 values in an array. So instead we can use a for loop. So I'm going to say for int I equals 0, this part's the same. And now I is less than names.length, then I++. So names.length represents how many values are in the array. It's the same number that we typed into the square brackets up here. So we can say names, and instead of at 0, now we're going to do names at I, because I is a stand-in for our index, which is why, if you were wondering earlier why we use I, this is why. I stands for index. So we want names at some index between 0 and names.length, whatever loop we're on. That's where we want to access it in our array. So I'll just create a scanner. I covered this in the Getting User Input workshop. So if you are unsure how a scanner works, I'll refer you to that, or there's plenty of videos online and everything like that. But so we can say names at I equals input.next line. And now this will fill our array with names that the user types in. If we want to print out those names, we would need another loop for int I equals 0, where I is less than names.length. Doing that, I++, and then sysout names at I. So whatever 5 names the user types in, we have a second loop that goes through that array and prints out those 5 names in the same order. So this is why loops and arrays are so handy. That's why they go together so well. Now I want to go back to that for each loop because I can rewrite this using that instead. Going back to that syntax, it's for and then the data type. So that data type represents what kind of data the array is storing. In this case, our array is storing strings. So we're going to say for each string, and then we want to give it a name. So you can call it S. That's a pretty standard one because it's a string. If we had an int, it would be I, so on and so on. Or you could say for each name, and then with the colon, I like to say that's int. So for each name in names, which is our array, our collection, we're going to do something. So for every string variable called name in our array called names, we're going to print out name. So this does the exact same thing as what we had before, that for int I equals 0, I is less than names.length, I++, sysout names at I. This accomplishes the exact same thing, except we don't have a variable representing the index. We have a variable representing the value located at that index. And now there's one more thing about arrays that I want to go over, or I guess a couple more things, but one important thing is I think it's important to know how to swap 2 values in an array. So let's say we have an array and there's 5 values in it, not 55. I'm going to say array at 0. Actually, let's use the loop fill it. So this is the same for loop that we've been using to iterate over arrays. And I'm going to say that array at I equals I+1. So whatever the value of I is, we're going to add 1 to it and set that as our value in our array. So we're going to say for each int I in array, we're going to print out that I value. So this should give us 1, 2, 3, 4, 5. Now let's say I want to swap 2 of these values. I'll swap 1 and 2. The way we do that is we need to store a temporary value. So I'll do it in between here. So the temp value is always going to be the same data type that's being stored by the array. So array is storing ints, so our temp value is going to be an int. And this is for swapping index 0 and index 1. So we're going to set temp equal to one of the values stored by these indices. So I'll start it equal to 0. So int temp equals array at 0. Now we can say array at 0 equals array at 1. And lastly, array at 1, we set back to temp. So we've just gone in a big circle. And now those two values have been swapped. We took 1 and put it here instead. We took the 2 that was here and put it where the 1 was. But we need this temporary variable to act as our middleman so we can swap them out. The swapping isn't really important until you get to sorting, but I wanted to at least provide you with this information so that if you do need to swap something in an array, you know how to. Because there are some times where you'll have to swap something even if you're not sorting. And then I also wanted to cover a couple more ways to initialize an array. So I mentioned we need these square brackets, and that's true, but we can also put them in a different spot. So we can say int square brackets and then the name of our array, or we can put those square brackets after the name. And both of these are okay. They're both valid. Another thing we can do is fill in the values of our array as we initialize it. So if I know I want this array to be filled with 1, 2, 3, 4, 5, like we previously had down here, I can use the curly brackets to do that. So I can say fill this array with 1, 2, 3, 4, 5, all separated by commas. And now those values are automatically in the array. And I don't have to use a for loop to fill them in. Sometimes this can be helpful. The larger the array, as in the more values you're putting in, the less helpful this becomes because that means you're still having to type them all manually. But this does come in handy once in a while. And I also wanted to go over one last thing as we're getting close to out of time and I want to make sure everyone can still ask questions if they need. There's something called default values. So when I create this array, int array arr equals new int, and we say it's 5 values. Going back to that IKEA model, there's nothing in this string, right? All we did was built it. It's in our house where we want it to be. And that wasn't entirely true when I said that there's nothing in it. There's no meaningful data in it, but when we create an array, it always fills it with default values. So the default value for an int is 0. So if I were to print out every value in this array, they would all be 0. If I were to make this a Boolean array, and remember that Boolean means true and false, the default value for a Boolean is false. So these would all be set to false initially. Any number, the default value is 0. Same thing goes for char, because char is technically just an int behind the scenes. And when we print that out, it's printing out the character associated with 0. So it's just a weird random escape character. I don't know what it equals. You'd have to look at the ASCII table. And lastly, the string default value is null, because string is technically an object, and we're going to cover classes and objects in November, but the default value for a string is null. And so this is what you want to avoid because it's very easy to get a null pointer except. So you want to make sure that you're actually filling your arrays before you start using that. Okay, I think that's everything I wanted to go over. So were there any questions that anybody had about anything, any loops, for loop, while loop, arrays? Okay, all good. In that case, thank you for coming. Thank you for watching. If you have any questions to anyone who is watching this now or watching the playback of this, you can email me at nhout2@uis.edu, and I will get back to you when I can. And also feel free to set up any appointments with the Learning Hub. We have multiple computer science tutors, so even if I'm not available, someone else will be able to assist you. But that's that. Thank you again for watching. Hopefully this was helpful. I hope I didn't miss anything, and have a good day.